Welcome. The topic today is on physics and we have friction. The question reads, a metal block A of mass 40 kilograms requires a horizontal force of 100 newtons to drag it with uniform velocity along a horizontal surface as shown. So we have the diagram, we have block A and a dragging force. Roman 1, calculate the coefficient of friction. Then Roman 2, another block B of mass 50 kilograms requires a force of 125 newtons to drag it along the same surface. The two blocks A and B are now connected together with a tow bar and a dragging force of 275 newtons applied to pull them along the same surface as shown. Then A, determine the acceleration of the system, and finally B, the tension of the tow bar. So for part A, we have a block being pulled along a given surface, so we have a dragging force. So block A has a mass of 40 kilograms and it requires a force of 100 newtons to drag it. So note that the dragging force is directly proportional to the reaction force, and this also implies that when you introduce the equal sign, then we need to bring up a proportionality constant, and for that case we'll use the letter mu. So we have mu r, where mu represents the coefficient of friction and r is the reaction force. So besides this, we also need to recall that action and reaction forces are equal, so the reaction force is equal to the weight of the block, which is given by mg, mass times gravitational acceleration. So assuming we had the center of gravity at this particular point, then the weight of the block will act downwards, which is mg, and then we have an equal and opposite reaction force, which is r, acting upwards. So that is where we get all this. So in place of r, we are going to replace it with mg. So we have force is equal to mu into mass times gravitational acceleration. From here, we can now do the substitutions. So we know that the dragging force F we are given as 100 newtons. We know that the mass of the block is 40 kilograms. So we're given right here. And we also know that the gravitational acceleration of the Earth is 10 meters per square second. So what is missing is mu, which is the coefficient of friction. So doing our substitution in this formula here, we are going to have 100 is equal to mu into 40 by 10. So that means mu is 100 over 400, and that is 0.25. So that is the coefficient of friction. Right to the next part, Roman 2, another block B of 50 kilograms requires a force of 125 newtons to drag it along the same surface. The two blocks A and B are now connected together with a tow bar, and a dragging force is applied as shown to pull them. So what is required is the acceleration of the system. So the system here is a combination of block A and block B being pulled together along the surface, and you also have the tow bar connecting B and A. So in order to get the acceleration of the system, we need to note that force is equal to ma, mass times acceleration. According to Newton's second law of motion, force is equal to mass times acceleration, and this is the resultant force. So this is the force that keeps the system in motion. So for this particular case, the resultant force MA will be obtained by 275, which is the force applied, and this force has to overcome the frictional force acting on B and the frictional force acting on A. And the frictional force on B and the frictional force on A are simply the forces required to set A and B in motion. Remember, for the first part, you're told that block A requires a force of 100 newtons to drag it, and for B requires 125 newtons. So those are the respective frictional force. So we have mass times acceleration is equivalent to 275 minus the friction on B, we now know is 125, plus the friction on A, that is 100. So the resultant force MA is equal to 275. So here we have 275 minus 125 plus 100, that is 225, and that is 50. So mass times acceleration is 50. But the mass is mass of B plus mass of A, and that is 50 plus 40, which is 90. So this should imply that 90 times acceleration, so we are substituting here, should be equivalent to 50. So that A is equal to 50 over 90, and that finally is 5 over 9 meters per square second. So that is the acceleration of the system. Finally, the tension of the tow bar. So again, when the system is in motion, A pulls B via the tow bar. So we have some tensional force on the tow bar. So this tensional force is what we are required to get. So again, we are going to apply Newton's second law of motion. So we have the resultant force MA given by the tensional force has to overcome the frictional force on B. So that means we can rewrite this equation as T is equal to MA plus the frictional force on B. So tension on the tow bar is therefore given by the mass of B. Remember, we are pulling block B, so therefore this will be the mass of B. So mass of B times acceleration, and the mass is 50 times the acceleration we already have as 5 over 9. And then we add that to the frictional force on B, and we already have it as 125. So this should give us, for the first part, we have 27 and 7 over 9. We add that to 125, so that finally we have 152 and 7 over 9 newtons. So that is it for this question. Thank you for your patience. Thank you for watching. See you in the next video.